Hello friends, and today we are here to discuss the chapter Light. Welcome to the second sequel of Light. And today we will be discussing what are the uses of the concave mirror that we discussed in the previous lesson, the previous session, the mirror formation of, the image formation of. So you can guess that the concave mirror can be used to concentrate the light at one point. So this property is quite big, and it can also diverge the rays from the focus. So these two properties, keeping them in mind, are the uses of the concave mirrors as follows. Concave mirror is used in torchlight to get powerful beams of light. So how does this happen is that, this is going to be my torch. The light is going to pass from the focus, and as it passes from the focus, I'm going to have parallel beams of light. So that's why concave mirror is used here. Concave mirror is also used in satellites. For example, this is my concave mirror. A satellite signal is coming. So the receiver is here. So the signal is coming. It's going to concentrate the rays to the receiver. And so the receiver is going to have this. So this is also used for these purposes like satellites, etc. So now we are going to go on the image formation by our convex mirror. So one thing to refresh your mind, what is the difference between a convex and a concave mirror? The focus is at the back of the convex mirror while it is in the front of the concave mirror, and all the radius of curvature, the principal axis, all of them lie at the back of the convex mirror. Again, we are going to do the same things, but keeping one thing in mind. We are not actually going to, make the points meet, because everything is going to happen at the front of the mirror. Nothing is going to happen at the back of the mirror most of the times. Though the image can be formed here, but the reflection and the incidence is going to happen here only. The image can be formed here, but the incidence and the refracted ray are going at the front of the mirror. So keeping this in mind, we are going to see that it happens to meet after extending the rays parallel which meet at the focus, which are supposed to meet at the focus, are going to appear to diverge from the focus instead of actually meeting at the focus. And the second thing that we have to keep in mind is the same for the center of curvature. They are going to be directed towards the center of curvature, not actually going towards the center of curvature. So there are only two image formations for the convex mirror, and hence is nice. So if the object is placed at infinity, what is going to be the scenario? This is my convex mirror, and the images are placed at the infinity. So they are going to appear to meet at a point focus. So the image formed here would be highly diminished, point size, virtual, and erect. Then the second thing is here. When the object is kept in the front of the mirror, then the image is going to be the same things we are going to repeat. It's going to go parallel, it's going to appear to pass from the focus, it's going to appear to pass from the center of curvature. So they meet here. Okay, so the image is going to be formed between the pole and the focus. Image here is going to be diminished, virtual, and erect. So why was I highlighting the words virtual and erect? Because in the concave mirror, all of them are real inverted, real inverted, real inverted, and virtual and erect. Here it's virtual and erect and virtual and erect, no real and inverted. That is the speciality of the convex mirror. So now going on to the uses of convex mirror. You might have seen that, while driving, your father tends to look up. Okay, the truck is coming. Okay, I'll take my car that side. So the rear view has a very big function. It gives us a wider view of the landscape instead of giving a small one. So that is what convex mirror are used for, to give a wider landscape, wider view of the landscape, because they diverge. They are known as diverging mirrors, and concave mirror are known as converging mirrors. So as they diverge, they give a very wide view of the landscape. So hence it's it's comfortable for the driver to see in the convex mirror and drive. So it is also known as the rear view mirror. Okay, so having you told everything, now I'm gonna go on to the sign convention. You all know what is the Cartesian plane. That's in mathematics though. You might be thinking that have I gone crazy that I'm thinking mathematics in the physics class. That is because it's quite related to the sign convention. Okay, so what is a Cartesian plane? In a Cartesian plane, x, y dash, x, x dash. Same goes here. So in the values towards the right here in the Cartesian plane are going to be positive here, negative here, positive here, negative here. Same as the sign convention. If we are taking the distance towards the right, then it's going to be positive, and if we are taking the distance as towards the left, then the distance is going to be negative. If we are taking the distance upwards, then the distance is going to be positive, but if we are taking downwards, then the distance is going to be negative. So this is the sign convention. So based upon the sign conventions, there are some conclusions that you can gain from the convex and the concave mirrors. Okay, this is my concave mirror, this is my focus. So what do you think? I'm going, while counting the distance of the mirror, of the the focus from the mirror, I'm gonna go towards the right. Okay, towards the right. So the focus is going to be positive. I'm sorry. So how can you channelize this? It's yet another way. If the distance is going towards the mirror, if the distance is going towards the mirror and mirror is towards the right, so obviously it's going to be positive. But what about the focus of the convex mirror? The mirror is towards the left, so for the focal length we are going to go towards the left, so hence it's going to be negative. So the focal length of our concave mirror is going to be positive, while the focal length of a convex mirror is going to be negative. Same stands for the radius of curvature and the principal axis. Then we're going to go on to the second thing, that is the mirror formula. The mirror formula says 1 upon V plus 1 upon U is equals to 1 upon F, and everything goes over my head. So now I'm going to explain what means 1 upon V. 1 upon V. V means the distance of the image from the mirror. So you're going to keep the sign convention in mind. If I'm going to say that the distance of the image or from the, the distance of the image is in the front of the mirror, in the front of the convex mirror, then it's going to be positive. But at the back of the convex mirror, it's going to be negative. Same stands here for the concave mirror. If it's going to be at the back, that is the object is being placed between the pole and the focus, then the image distance V is going to be negative. So you're going to take the sign convention in mind. Second thing to be remembered is 1 upon U. 1 upon U means the object distance. So what is the distance of the object being placed from the mirror? Here again you're going to see that right left funda, as I said. In the front of the concave mirror, the object distance is always going to be positive because it's going to be towards the right. Then 1 upon F, that is the focal length. For the convex mirror, it's going to be negative, and for the concave mirror, it's going to be positive. So keeping the sign conventions in mind, this is going to be the mirror formula. The last formula I'm going to discuss in this session is magnification. So magnification is h dash upon h. H dash is the height of the image and h is equals to the height of the object. So h dash upon h gives you the the magnification of the image that has happened. It can be in minus or in plus, it depends. And the magnification is also equals to minus V upon U. That is minus the distance of the image from the mirror and upon the distance of the object from the mirror. I hope that you have understood this chapter, and if you want to know more about this video, you've got to see my other videos as well.